Alright, here's part 2 on solving two-step equations. Now let's review something when we see a division sign. Remember, fractions are division. So if you see m over 2, again, remember, this is the same as saying half m. Anytime you have a 2 in the denominator, that means half anyway, right? So that's half m. So if you saw this, what do you think that would be? 1/6 of m. And what if you saw this? 1/7 of m. Okay, let's look at this question. Put that in focus there. Okay, there we go. I thought I needed glasses there. Now, what do you think we have to do here? We have two of the same variables. Remember, we only want one variable. And remember, we can combine like terms. Remember from 7th grade. So, we don't want to plus the 6b out because then we'll get a 0. We never want a 0 in our equation, in one side of the equation. So we'll minus the 5b on both sides. Cancels. Minus the 5b. So now, remember, whatever you do to one side, do to the other. And we're combining like terms. We did this in 7th grade. So now we have a minus 6b minus 5b. You could just ignore the b's for now and just say minus 6 minus 5. Right? So that becomes keep change change, a minus 11b equals 2. So the b is not alone yet, so we have to divide the negative 11 on both sides. And b would equal negative 2/11. Now let's check to see if we're right. So we're going to replace negative 2/11 with b and see if they equal each other. So we're going to say 5 times negative 2/11 and negative 6 times negative 2/11. So try that, see what you get. Alright, so let me write this over. I'll do negative 6, and we're going to times it by negative 2/11. Remember, that's when you see parentheses, it's multiplication. You can put the 6 over 1. So here you have a negative times a negative. You know it's going to be positive, so this will be 12 over 11. Let's see if it equals the same on the other side. So the other side, we're saying 5 times negative 2 over 11. That will give us a negative 10 over 11 plus 2. And if you added this, we should be able to add integers at this point. This will become a 1 and 1/11, which is 11 times 1 is 11 plus 1 is 12/11. So it equals out. So again, b was negative 2/11. So rewind the tape if you didn't understand that. What if we saw something like this? Okay, the first thing you want to do is make sure you clean up the subtraction. Remember, subtraction always becomes addition with keep, change, change. So keep the negative q over 4 plus, we're going to change it to 7 equals 3q. So we have q's on both sides here. We want to get rid of this one first, because if we get rid of this one, we'll get a 0. Remember, we don't want a 0 in an equation. So we're going to, this is a negative q over 4, so we'll plus the q over 4. Cancels, and we're going to plus the q over 4 on this side. Right? So we have a negative q over 4, we plussed it, we brought it to this side. Right? And now we have a 7, so we have 3q plus q over 4. Remember, q over 4 is just 1/4 q. So we have 3 and 1/4 q so far. Now what do? We need the q alone. So we're going to divide the 3 and 1/4, or 3.25 if you want to use a decimal. So divide that out, we'll bring this up. So we're going to divide now 3 and a quarter, cancels, and we're going to divide 3 and a quarter on that side. Okay, so I'll just keep that there for a minute so you see it. So now, let's do this over now. We're going to divide 7 divided by 3 and a quarter. So we'll erase this. And we have 7 divided by 3 and 1/4, which you can make improper. 4 times 3 is 12, plus 1 is 13, so it's 7 divided by 13/4. Here we have our complex fraction. So what we're saying now is 7 divided by 1, 7 over 1 divided by 13/4. We flip the fraction with division, and we have 28/13. So we're saying Q is 28 over 13. Now let's see if it makes sense. And you can simplify this also. But let's just use the 28 over 13 first. A lot of students like impropers when they're dealing with linear equations. But you could do whatever you want. So let's use 28 over 13. We'll go back to the original problem. Now Q, instead of being Q now, it's 28 over 13. 28 over 13. So we're saying 3 times 28 over 13. And here we're saying 28 over 13 divided by 4, and it's negative. So let's solve that. Erase this. Let's do the first one. It's 3 times, remember that's the times sign with parentheses, 28 over 13. Alright, so 3 times 28 is 84. So we have 84 over 13. We can keep that for now. Let's see if we get 84 over 13 on the other side. So we know this one's 84 over 13. So let's look at the other one. Now the other one we said was 28 over 13 divided by 4, and was a negative, minus 7, which we know becomes plus 7, plus, right? Keep change. Let's bring that over. Good. Now, so we're saying now 28 over 13 divided by 4 over 1. And we have a negative here. So this answer will be negative. Okay, so negative 28 over 13 times 1/4. And we get 28, and we have 13 times 4, which is 52. And remember, that's a negative, so it's negative 28 over 52. And don't forget, we have to plus it by 7. So these are the steps. Let's plus it by 7. Bring that over here. Remember, we have to get 84 over 13. That was in order for this to be correct. So I'll get it. So we're saying now negative 28 over 13 over 52 plus 7. You could do this vertically if you want. So we want to get a denominator here. So we're going to cancel the 7, make that a 6, and this will be 52 over 52. Whatever we borrow one number. We're borrowing the denominator. So now we have a positive 6, and we'll have a positive fraction here. So it's 28, negative 28 plus 52. So we get 24 over 52. Okay, and now, so here we had, remember, on one side we had 84 over 13, but now we have this 6 over 24 over 52. Well, let's look at this. We have the same answer. I'll bring them over here. 13, I'll bring this down so you see it. 13 goes into 84 6 times. There's our 6. And then that becomes 78. We have 6 left over. Now, so how are these the same? Well, we reduced it. Bring it back up here. So 4 goes into 24 6 times, and 4 goes into 52 13 times. So we have the same answer. Okay? You should review that. That was a complicated one. You won't see too many of those, especially on state tests. But if you can do that one, you can do many two-step equations. Okay, so here is a challenge now. Let's say you saw this word problem. And it says 3 consecutive even integers that sum to 48. Can we make an equation with that? So look at it carefully. We need 3 numbers, and they have to be consecutive even numbers. So we have an A for a number, a B for a number, and a C for a number, and they have to equal 48. These are our 3 numbers. When we're making linear equations, we only want one variable. We don't want A and B and C. We just want either all A's or all B's and all C's. So we have to try to make them all A's or all B's or all C's. So how can we do that? Well, we know that they're consecutive and even consecutive. What does that mean? That means that B has to be 2 more than A, right? If they're even numbers. It can't be 1 more, it has to be 2 more. And C will have to be 4 more than A. So now we can do substitution. And this is very important substitution when we start doing other equations. So I can say here A, instead of saying B now, I can say A plus 2, because isn't B A plus 2? Whatever A is, it's 2, B is 2 more than it. That's why I'm putting it there. And C is A plus 4, and it equals 48. So far we have that. A plus 2 plus A plus 4 equals 48. 2 and the 4 because we're saying they're even integers and they're consecutive. Now, even if it was odd integers and they were consecutive, it would be the same thing. We can combine like terms. There's 3 A's here. If there's 3 A's, let's erase this. I can combine all the A's. Now there's 3 A's. Plus 6 equals 48. Where did the 6 come from? Well, we had a 2 and a 4. Now, here's our equation. We can minus the 6 on both sides. 48 minus 6 is 42. So, divide the 3 on both sides now. And what is A? Once you know A, you know B, and you know C. So, bring it up here now, bring this down. So we know that A is 14, B has to be 16 because it's 2 more, and C has to be 18. So 14 plus 16 plus 18 have to sum to 48. If they don't, we didn't do it right. So here we have 14 plus 16 plus 18. If you add them together, you'll get 48. So that's how we do this challenge question. 3 consecutive integers that sum to 48. Great job.